This video will demonstrate how to find the domain of a function. So we have 4 examples here. First, A, we want to find the domain of the function f of x equals x squared plus 5x. All right, so first we want to know what can x be, because that's what the domain is, right? All the x values. And you probably can tell x can be anything, any number here. There's no value that x cannot be equal to. So for this function, the domain is all real numbers. You can write it in a set like this. It's all such x that x is a real number. Or you can say the domain is all real numbers. Or if you want to represent it in the interval notation, that will be from negative infinity to infinity. Okay, so either way. All right, so for B here, find the domain of the function g of x equals 3x over x squared minus 4. So what x cannot be equal to for this function? Let's look at the denominator. We know a denominator can never be equal to 0. So in this case, we have some kind of restriction that x squared minus 4 cannot be equal to 0. All right, let's solve this inequality. Well, if we factor it, that will be x plus 2 times x minus 2. This number cannot be equal to 0. So that means x plus 2 cannot be equal to 0, or x minus 2 cannot be equal to 0. So x cannot be 2 or negative 2. To represent it in the set notation, we will have x is such a number that x cannot be equal to 2 or negative 2. This is the set notation. If you want to represent it in the interval notation, let's draw a graph to help us understand the situation. Well, actually, let me not draw it over here to cause more confusion. Let me draw it over here. So it is a set of number that only negative 2 and 2 are excluded. So this interval will be from negative infinity to negative 2, which is this part, union this middle part, which is negative 2 to 2, and union this part, which is negative 2 to infinity. So this is another way to write your solution. Okay, now let's look at the third one. Find the domain of the function h of t equals square root of 4 minus 3t. So for this problem, this number 4 minus 3t is underneath the square root. We know the number underneath the square root cannot be negative, right? In other words, 4 minus 3t, this value should always be positive or 0. So greater than or equal to 0. Solve this inequality we have. You can move the 4 over. Divide both sides by negative 3. So since we're dividing a negative number, this sign of inequality should switch to the other direction, and your answer should be t is less than or equal to 4 over 3. If you write it in a set notation, is all such, in this case is t, all such t that t is less than or equal to 4 over 3. If you want to write it in an interval notation, let me draw a little graph here. Say this is 4 over 3, and since we have the equal sign there, 4 over 3 is included, and t is less than or equal to 4 over 3, so this way. So it will be from negative infinity to 4 over 3, where 4 over 3 is included. We use bracket instead of parentheses. So here's the solution. All right, the last one. To find the domain for this last function d, we have to look at two parts. One is this value underneath the square root. Well, this value, 3x plus 12, needs to be positive or 0. And also another thing is we have to look at the denominator here. X minus 5, this number cannot be equal to 0 because a denominator cannot be equal to 0. So let's solve each inequality. To solve the first one, you have 3x is greater than or equal to negative 12. Divide 3 on both sides. Since you're dividing a positive number, you do not have to change the inequality sign. So x is greater than or equal to negative 4. Over here, solve this inequality. X cannot be equal to 5. All right. So we have to satisfy these two conditions at the same time. All right. So for our domain, let's draw a graph to help us understand the situation. So this is negative 4. It's all x that is greater than or equal to negative 4. So from negative 4 to infinity, but x cannot equal to 5. So this is excluded. So if you want to represent it in the interval notation, that's from negative 4 to 5, parentheses talking about this part, union from 5 to infinity. Okay, of course, if you want to write it in the set notation, it will be all such x that x is greater than or equal to negative 4, and x cannot be equal to 5.